Welcome to this guide to understand the initial commit of a Phoenix project. Let me introduce myself first. I'm Jorge Bejar. I work as a CTO at WideWorks, and that's a company located in Uruguay, Montevideo. And I'm very proud to be part of such good people, talented people that are part of the team of WideWorks. We hack with Ruby, JavaScript, and of course, Elixir. And the motivation for this talk today, it was because I have many years of experience working with Ruby on Rails, doing web development. And when I started learning Elixir, like 2 years ago, and Phoenix, of course, I felt like in home because I was able to develop websites, web applications, making use of most of my experience I had with Rails. And that's because, I don't know, I think that the thing is that Phoenix as a framework takes much of the good things from the Rails community. But at the same time, there were a bunch of differences that are pretty obvious, like the technology itself, the functional programming that is not the same, that object-oriented programming, of course. And spending a little more time on that, the more I learned about Phoenix, the more I became aware of what makes Phoenix special. So this is the story for today, to share a little about that. For the first half of this talk is going to be a tour. We will be reviewing or learning a little more about some important files that are part of your initial commit. I'm not talking about knowing the internals, the internal source code of the inner mechanisms of the framework. It's more about better knowing the code that you are not writing by yourself, but you're still adding into your repository. So let's start looking at the lib folder, and let's distinguish two main areas. First, we have something that is what we call the web interface code. This is the part of the project that helps you to communicate, that helps the application to communicate with the external world. It first deals with the commit requests and shapes the responses, and also manage all the ongoing communication through the sockets for the channels. And we will have this business logic part, mostly including your custom code of your application, your domain logic, and of course the part of the system that models your data and the database specific part. There is a fact. The web interface code depends on the business logic. And it shouldn't be true in the other way around. There is a little exception here, which is the application module, which is not part of the business logic, of course. And this is important because all OTP applications, and Phoenix applications are OTP applications, must implement the application behavior. This behavior, especially the mandatory function, is the start function, which is the one that is going to be executed when your application is actually starting. And let's look at the code that is being added by Phoenix. This is the part of the code in this application module that is specific for Phoenix applications, code that the framework is generating for us. And looks like everything, or almost everything, points to this module, the endpoint module, which is a very important one. So let's speak about it a little more. This module has three main responsibilities. That's what it says in the online documentation. I'm just repeating that. But let's speak about those responsibilities. The first one, it starts and supervises all the processes that are needed to handle requests into our applications. I mean, it implements the proper web server part, the part that handles or manages or deals with the network requests. Of course, most of this complexity is granted by the framework. And the only part that we need to have in our code is to make sure that the endpoint module is one of the children of your main supervisor process of your application. Also, this endpoint module hosts the web-specific configuration. This is specifically the configuration that needs to make work all the things that the endpoint is doing. But let's think that most of it is runtime configuration. It's configuration that the framework uses ETS tables to manage that. And that can be read and also modified when the application is already running. And for this reason, it needs a mechanism to update this configuration in case you update the configuration and do hot upgrades, which is the ability on TP application to update your code without restarting the node. In this case, it's making use of the optional config change callback from the application behavior in order to make that work. But it's code that you have in your repository. It's not internal. And finally, it's time to speak. We are just looking at the code of the endpoint module. We were just looking at the application module. And most of the code that we can see here leads to the next topic of this talk, which is the plugs. Because the responsibility number 3 is to define an initial plug pipeline. I'm not talking today of most of the WebSockets part, channels, and this is going to be an explanation of how the regular HTTP request works. So let's start speaking about plugs, which is a crucial concept on Phoenix applications. I was told that we will have a lot of them, each one doing a bit of the work, passing it to the next one in the assembly line. I like to think of plugs like being the Oompa Loompas of your applications. It behaves a little like this. If you are like me, coming from other MVC technologies like Rails, or you have the same in Express.js and other frameworks, you have the concept of middleware components. And here is not so far. I mean, it will be the equivalent part of in Phoenix. Phoenix are like these pieces of code that make some calculations before and after the response is calculated. What is the middleware components are used for that in different MVC technologies. However, here is like crazy. I mean, you can use plugs for everything, and they also take part of the main calculation of the response part. It's like in Phoenix, you will use this interface all the time. So let's explore an example, by example, of what it looks, how it looks to process an HTTP request by only using plugs. That it's a good introduction or way to understand what is going on inside the green box. So let's start saying that when in your Phoenix application an incoming HTTP request arrives, you will have a connection extract, a plug con extract that is going to include all the request information. Then, using this information, the idea is to invoke a piece of code that corresponds to our first module plug. A module plug is a plug that implements the plug behavior that is being implemented by the plug library. Of course, the plug library is one very important dependency of our project. And the most important part is to implement the call function, which is the one that is going to receive a connection extract and returns another connection extract with some sort of modification, usually additions or things that are modified. In this case, we are making use of a helper function from the plug library. We have a bunch of these kind of helper functions that help us to put right information in the right fields of this extract, of this connection extract. In this case, it's just an example of setting the content type header that the framework is going to use to build a response. It was the first plug, but by using the output of the first plug, the idea is to pass it to the next plug in the line. Will be the input of the next one. And again, it's the same, invoking a call function that makes something and create a new version of this connection extract. Here we are making use of the assign function, that is a mechanism to put some, you have an assigned field in this connection extract that you can use it to put just custom information, something that is specific of your application. And the idea is to make use of this information in a further plug in the processing. If you are already using the framework, you already know this concept because it's the way that the framework has to pass information from the controllers to the views and template layer. It's just making use of these mechanisms. And then, just running a final example, the idea is to arrive to a final plug or some plug in the process that actually calculates the response body, the response status. For example, using, this is one of the basic helper functions from the plug library, which is the send resp. And at this point, the framework is able to build a proper HTTP response. And we did it only by using plugs. Also, by running this example, we take the opportunity to speak about the three types of informations that the connection extract holds. The request information is like read-only data about the request, the custom data, the assigned field, and the response values. You have to make sure that you will have a response code, a response body, and the HTTP headers, of course. OK, let's speak again about the third responsibility of the endpoint module. But let's say that, and please take in mind that all the examples I did, because it was just an example on the air. But let's translate that to what is really happening or going on in a Phoenix application. And the first thing to know is that this endpoint module is also a module plug in its own. And it's going to be the first plug to be executed. This is the first plug that is the first plug, the one that is receiving the connection extract with including only the request information. Internally, it has an implementation of the call function. This is just a simplification. But the main thing is to make use of the plug builder module or feature from the plug library that helps you to orchestrate to make the whole pipeline work. It's the one that does the job that I just explained in my example. Pass the first version of your connection extract to the first plug, takes the output, and then pass it to the second one, and so on. You can do it pretty easily by using the plug builder. You can do it if you need it for some reason. It's just a available feature of the plug library. The last step, the last plug in this pipeline, by the way, this pipeline is one pipeline that applies to every HTTP request. All your HTTPs, all your requests, given an environment, are going to be run through this list. And the last plug is one that you're already using, if you're using the framework, of course, which is the router. And the router, as a plug, internally in the implementation of the call function, I'm not going to show the internal code this time, but makes a very specific show, as every plug does, which is something that you probably are familiar with, but it takes the connection extract, identifies the route, and passes the request information to a new plug pipeline. This is a plug that also manages a new pipeline. In this case, that is going to depend, the execution is going to depend on the path at the HTTP verb, as you already know. And finally, this is an example of a request hitting the home page. It takes the result from the local pipeline and passes this connection extract to the appropriate action function from the corresponding controller. And the action functions are like, we were speaking about module plugs. There is a concept that is very similar, which is function plugs, which are like the call function from the modules. I mean, it's a function that receives a connection extract and has to do something and return a connection extract. And your action functions in the controllers are like this. And since this is the last plug in the list in real Phoenix applications, here is usually where you calculate or compute the response of your request. Of course, you make use of all the things that Phoenix set up for you, the views, the templates, the render function. But it's just a matter of knowing that it's good to be aware that the render function, for example, is internally relying in this send-resp function that I used in my example. Pretty easy. This is from the documentation, online documentation. Yeah, controllers are also plugs. I mean, it's like a full plug-oriented architecture. It's funny to know that each route declaration in your controllers could be translated, or it could be like, yeah, it's the same that the manually invoking the call function of your controllers. I mean, the call function is something that you don't see in your code. But, and of course, you have to pass the right atom, so the proper function application is actually executed. OK? Just to finalize this, the first half of the talk is going to be this tour. Let's go in to mention now, or to present one special module. This is not a plug, but it's an important one, and it's the web interface module. I must confess that I don't know if this is an official name, or it is the name I'm giving today in this talk, but I'm referring to the module that has the name of your application and the web ending. This is what I'm calling the web interface module. It's this module that Phoenix generates for you that have or includes this controller, view, router, channel functions by default, and where we usually we start with something that the framework puts for us, because it's importing, in this case, it's for controllers. These are the use, import, alias, and these kind of lines that help you to import the right functionality from the framework into the right place in our code. Developers using Phoenix usually add more and more lines here, because it's like the centralized place where we can import functionality also from other libraries or from other parts of our system. And everything is going to be injected in different types of modules. I mean, this code is going to be injected in controllers. And the same will be for views and the other things. But let's explain because this code is injected. I mean, if you already are familiar, how many of you are familiar with metaprogramming? OK, I think that is going to be just a review of that, but it will be informative if you don't know that. You may already know that the use directive could be equivalent to require the module and make an invocation to the special using macro. I mean, this is the code that this use line is what we have in controllers usually. We have to use the web interface module and pass the right atom, in this case, controller. So it's going to be equivalent to this, and we already have an implementation from this using macro in our web interface module. I mean, it's part of the code that Phoenix makes for us. And it's just a matter of, I mean, it's using the apply function that is the one you use to invoke a function when the name of the function is given dynamically. So it's the same that at the end, it's just in this way, it's able to inject these lines in each of your controllers. It's going to be the same for the views and so on. OK, that was the first half of this talk. And here is just a review of that, or just a quick recap. I think we mentioned some of the important files that take part of, especially of how the framework processes your HTTP request. I didn't mention the more known part of the framework, like the ecto, the controllers itself, like controllers, the views and templates. I wanted to today focus on the things that we usually have in our project, but we just take as granted. Remember that at the end of the day, each request will be handled by a sequence of orderer plugs. I mean, it's just going to be like a row of functions invocations until we have a final version of this connection extract. Great, so far. We just speak about what Phoenix made for us. And I think that this code is oftentimes kept without modifications. But it doesn't have to be the case for all types of applications. I think that the default Phoenix project is a very good default. You can use it in many situations. But I also think that there is room to make modifications, to adapt it, to make changes, to have more tailored solution for different situations. So now it's an invitation to, I will be doing some examples of different situations and discussing how we could modify that files. Let's start with, again, looking at the web interface application, and especially the controller function. And as it usually happens, we will have the default setup, the thing that was generated by Phoenix, but also a bunch of lines importing functionality in each one of our controllers. And as the time passes or your application grows, it's pretty common to have a bunch of things at the same time. So the question is, can we do something to prevent having all the features available in each controller? Let's start by doing a possible refactor. Let's just use the controller function for the basic setup, and then create a few functions, one function for each one of our features. Please note that we are invoking the controller one in each one of these specific controller functions. I'm also doing combining the quoted expression in the right way. Of course, you have to understand a little bit the metaprogramming part. And then it's just a matter of using this web interface module by passing the more appropriate atom. So you will end up executing during the compilation phase. I didn't say that, but the injection of the code happens in compilation time, right? We are not never we are modifying the source code of each controller, of course. Yes, this is just an idea, but I also find a limitation with this approach. What if we want to have more than one feature in one of our controllers? Let's say that this account controller, we need to the authenticator feature and also the cache controller thing. Okay, let's do some changes. Let's remove this invocation from the controller function. It's not logging invocated in each one. And then we can do things like this. I mean, taking advantage of, just get inspired on the original code. And in this case, I'm just providing a new clause for the using macro that accepts a list. And in this way, we can just pass a list of things. I'm not sure this is just an idea. You can be much more creative than me. But I think these kind of things could make sense as your code base growth. In this case, because in your modules, you could end up easily having a lot of things, capabilities, responsibilities. I think that could lead to better design. Now, it's time to speak. I have two additional examples. And both of these examples are something that I call reduced Phoenix applications. There will be situations where I'm going to reduce the number of things that we will have in our setup. And remember that most of those things were plugs. So I invite you to ignore that advice. We are going to actually remove or plug plugs. First one, I'm pretty sure this is a very common situation in today's world with microservice and the increased adoption of GraphQL. So what happens when you have a project that implements a GraphQL API? An application that is only an endpoint. Only one endpoint or GraphQL endpoint. And of course, we are going to use the phx library because it's the popular option in Elixir. It's a great library, by the way. And what we have to do, or what we can do if we use phx alongside with Phoenix. Okay, we are starting from this default setup. And the thing is that if you only have one endpoint, GraphQL endpoint, the router doesn't make sense because you don't have many paths, you don't have many roads. It's always the same. And of course, all the traditional components from the MVC pattern, the controllers, and the views, the templates, and so on, the models, you probably are going to use them through the GraphQL solution, but it's going to be replaced, most of that, with the proper GraphQL abstractions. And thanks that we have an phx plug library that implements for us a wrapper, like a plug interface, to use with phx. So let's see that in code. In code, we will have like a bunch of changes in our endpoint module. I'm just commented out several plugs that are not longer needed for a GraphQL solution, because these plugs that Phoenix add for us are more tailored or are really needed when you have a HTTP request that interacts with a browser. But we are now interacting with other clients, just doing the GraphQL stuff. And the most important part is to really replace the router and put in this place the phx plug. We could also be interested on make some additional custom things by only using plugs. And in this case, I just added a plug before the phx plug, just to limit the request to one specific path. Otherwise, I'm returning a not found error. I saw some example of doing that by using the real router, but I think this is a much simpler solution. But of course, if you need more complicated things, or if you have more routes, it's recommended to use the router, of course. Finally, don't forget this web interface module. I mean, let's use it as well. And of course, we are not longer to have things like controllers, views. I mean, it's most, but you still can use this idea of having a centralized place to import all the features that you will need in certain kind of modules, and do the same. I mean, you can have the resolver functions, schema functions, so you can use this web interface module from your resolver modules, so, from your schema module. I mean, I'm talking about GraphQL specifics, but if you are not up to date with GraphQL, just trust me that they are concepts in the solution. And finally, my last example today is one situation that I recently ran, and I had to figure out what to do. It's a very specific or special type of Phoenix application that it happened to be in the context of working on a library. I was working on a library, and this library it was meant to be used in Phoenix projects, so it has to do with, it does something in the middle of the whole processing of the HTTP request. It doesn't matter the topic of the scope of the library, but I needed a way in order to do integration test. I needed a way to execute, to invoke programmatically some sort of dummy application that it had to be a Phoenix application, or at least partially a Phoenix application. So what I needed to do was to remove especially the web server part. I mean, I'm not interested on starting a proper server dealing with the real network requests in my unit test, or integration test, but I just wanted a way, as a developer, to programmatically invoke the first plug that makes sense in my situation, at least. And in fact, I ended up doing something pretty simple, like having one router, one controller, and one action function. It's going to be the tiniest, it was actually the tiniest Phoenix application I have ever done for myself, at least. So let's check the testing code. I mean, this is just an example code of how you could invoke this mini application. You can create a fake connection extract. This is just by using some code from the plug library. By using Phoenix, there are other ways, but they are more integrated in the test harness of the Phoenix projects. This is just the raw way to do it with plug. And then it's just a matter of invoking the call function of our first module, as we explained so far. In this case, it's just the router. And here is the whole code that I needed to implement this mini application. Only 2 plugs were used to assemble this beauty. I think it's fair to say that, because you could say, okay, this is not a full Phoenix application. You're kidding me. That's partially true. But I think that, it's still using significant part of the framework. I mean, we are using Phoenix controller. We are using Phoenix router module. I mean, and here I'm not using the views on templates, but it could be used pretty easily if you are interested on. I'm making use of the text helper from the controller part. I mean, this is at least partially using Phoenix as a dependency. And for me, it's great to have this grind level control of, it's great to be able to just import a bit of the framework. That's something that is great in how Phoenix is designed. Okay, time is running, so it's time to have final conclusions, to leave some conclusions from my side. Please pay attention and think about the composability of the framework. I mean, you're provided with a lot of freedom. I'm still surprised on how easy it is to think about the solution. It's just like, I mean, if you read the Phoenix book, you will be example of using the pipe operation, and they explain a lot how the framework works in terms of using in terms of functions composition, which is one of the main important things that comes with the functional programming. I mean, you can add and remove components as you need. And of course, there are some hidden things or little dependencies that you still have to think about, but in general, I found it pretty doable. I also love the fact that in Phoenix, you get what you see. I mean, what does the meaning of this? You will have the dependencies. I mean, you will see in your code the lines that imports the right part of the framework in the right places. Maintainers of Phoenix and the related libraries had put a lot of effort on making these dependencies pretty explicit. I mean, if you look at the files that we just reviewed, you will see a lot of things that they could be done. They had another option, that they could put that in the internal code of the framework, but they choose to put in your code. And when we have a framework that enables you to add and remove components, and when our code depends on framework internals in explicit ways, I think we are enabled to make change, and making that change are easy. If you're like me, that comes from a bad experience in the Ruby community, Ruby land, I was used to think about to choose the right tool from the specific type of application. I mean, I had to do this reasoning all the time. Of course, Rails is a kind of a solution that could cover everything, but it's usually too much for some things. So here I find in this community in Phoenix the opposite thing. I mean, with Phoenix, you can adapt it. You can cover all these cases and more. I mean, and it's possible and easy to do that. And for this reason, I think there is less motivation to do more frameworks in this community. It's more like doing libraries like the Avdin plug. I mean, you have probably to provide new plugs, but you are going to use the same infrastructure. Of course, in order to do these kind of changes, it's a good advice to understand and better know how Phoenix works. But I think that it's also a matter of understanding how your own code works, including the code that you didn't write by yourself, the code you received from Phoenix. And it was the message. I hope that this talk was at least a source of inspiration and encourage you to better understand and keep trying with that. Thank you.